Hello, industry explorers. All right, so hello, industry explorers. My name is Siobhan Colleen, and today we are going to actually talk about rocket science. Yeah, you see it over there. You see that lunar landing right there. We have with us today.
We are going to actually.
Hey, Ava, can you turn down the volume a little bit? I'm hearing a little feedback here. So while she's doing that, I'm going to introduce our incredible guest. We have Ava, who is a guidance, navigation, and control engineer working on a lunar lander. She has always been passionate about space and space exploration. It's finally time to combine that passion with her 6 years of experience on launch vehicles. You know, when people are talking about complicated subjects, they often say, oh, come on, it's not rocket science. Only today, it really is. And I've got to know, Ava, how often do you hear that joke?
Oh, daily. Actually, daily.
See, when I tell a joke that's that common, I don't tell it because I'm like, okay, I know this person has heard it several times, and I can't do that to them. But I could not help myself because I don't get to talk to a literal rocket scientist every day. So, Ava, can you please explain what the aerospace industry is all about? Paint a picture of that industry.
So the aerospace industry is huge. There's so many different things that you can do in the aerospace industry. You'll see behind me a couple of my favorites. So on that side, wow, this is backwards. On that side, right, those are launch vehicles. They're things that you can work on in the aerospace industry. You can also work on lunar landers, which is what I'm doing now, or landers in general, spacecraft that get you to different worlds. And then you can also work on a lot of stuff that's really just here on Earth, right? At aerospace engineering, you can even work on airplanes, and that's something that we see and have in our day-to-day life.
Oh my gosh. What drew you specifically to aerospace engineering what drew you to space rather than, any kind of plane that we may fly within our atmosphere?
I always liked space. I remember when I was 5 and my mom would read me books, but she would read me books about Voyager.
Oh, wow.
And I always loved space. I feel like I knew all of the planets by the time I was 6, and I always had a really good passion for just space and space exploration. And I thought for actually a long time that I wanted to pursue astrophysics, because that to me was, the stars and space. Until one day I actually took a physics class where they talked about what you can do if you major in physics and astrophysics. And one of the things, the professor actually said a joke. He said, one thing that you can do with a PhD in physics is you can pretend to be an engineer. And I don't pretend to do anything, really. And so I immediately made an appointment to go check out, all of the different types of engineering. And they had just come out with an astronautical aerospace engineering degree. And that was perfect because it combined space and all of the different math and physics-y things that I was already really into.
That is absolutely incredible. So you are a guidance, navigation, and control engineer. So tell us what that means, and what are the other departments that you work with?
So as a guidance, navigation, and control engineer, or a GNC engineer, I get to interact with pretty much everybody when it comes to making a rocket or a spacecraft. It's really, really important because the GNC engineers are usually also in charge of modeling and simulation. So we'll actually we will develop the trajectory that the rocket or spacecraft is going to follow. We're in charge of everything that tells the rocket where to go. And so it's really, I joke, but it's true. We're in charge of making sure that rockets go pointy end up, because if they go pointy end down, people get really upset.
Oh my gosh. Okay, so wow, I'm gonna skip over here to what college degree is needed. You mentioned a couple, astrophysics, and that's where your professor jokingly said that you can pretend to be an engineer. And then there was the aeros. What was that engineering degree you mentioned?
So I went to school for astronautical aerospace engineering.
Astronautical aerospace engineering. Okay, I
Yes.
knew I was definitely going to mess that one up. I was going to say astro something engineering.
Yeah.
So if if you can't find do all schools have that degree available, or what if you go to a school and that degree is not available? Are there other degrees that would help you become a GNC engineer?
Yeah, actually. So a lot of times, if there's not a lot of interest for aerospace engineering, they will actually offer still a mechanical engineering degree. And that's usually one that can give you at least a little bit more of a broad overview of how things are going to work. And actually, for controls, sometimes people will major in electrical engineering and they'll get a chance to look to see how controllers work. And then they'll move into guidance, navigation, and control as they actually get more into the space industry.
I'm getting this oh no, it went away. I was going to make a little ticker that scrolls on the bottom so that people can reference that. I'll get that going in just a second. What are the if I'm a student and I'm totally burnt out from high school, right? But I know I want to go to college. I know that I want to become a GNC engineer. I know at least I want to be in the aerospace industry, but I'm just burnt out and I want to take a break. I want to take a gap year. What could I do maybe as a hobby or something that I could maybe pursue or try out in that time? What could someone do in a gap year if they wanted to still pursue aerospace engineering?
So I would highly recommend dive into your passions about why you actually want to be an engineer. Being an engineer is a way to creatively solve problems. It's not necessarily supposed to be all, I mean, it is hard, but hard is not necessarily scary, and it can still be fun, and there are a lot of fun aspects of it. So dive into those passions, and try to learn something that maybe you didn't learn in high school that would be relevant. So for example, you could actually learn how to code, and that would be amazingly helpful. And you can even make coding a game, and there are lots of resources that are on the internet. You don't even have to necessarily take a class to do it. You can just learn how to code for free online.
Now, for learning how to code, is there any specific programming language that you recommend?
So I know three with pretty decently. So actually, C++ is a really important one because a lot of companies are now using C++ to code their flight software. Python is a really good tool to have anyway. It's a good stepping stone to and a good first go if you really just want to learn how programming works and how code works. And then also MATLAB is also very common. Can't learn how to program in MATLAB for free online. Usually you get to school first, but you can learn C++ and Python at no cost. And if you know Python and C++, MATLAB will be pretty easy for you after that.
Those C++ and Python are ones that pop up all the time.
Yeah, they are quite common.
What are some certificates or certifications that may help someone on this journey towards becoming an aerospace engineer?
So there aren't really any certificates or certifications that you would necessarily need to get while you're in school. But one thing that you do kind of have to think about is aerospace engineering. A lot of times there are some great jobs that are available where you would work for someone like the Department of Defense or some other government organization. And in those particular cases, you may need to get a secret or top secret clearance. And so I would definitely suggest kind of looking into those and just making sure that the decisions that you're making in college are not going to prevent you from getting those, if that's something that you really want to pursue. So usually, for space, there's not that much of a demand for a top secret clearance, but you can work on targets or missiles. And usually if you're going to work on those, then you're going to have to get one of those.
Did you say targets or missiles?
Yes.
So what's a target?
So a target. So a lot of times when the government is going to make missiles, they want to make sure that it's doing exactly what they think it's going to do. And so they will contract out someone to make a target that looks like something that maybe they want to hit. And they'll actually do kind of a practice run, right? Where, nobody's gonna die, no one's gonna get hurt. They're just gonna practice and test out their technologies. And so they'll actually launch a target, and then a different company who doesn't talk to the company that makes the target will work on the missile and the technological advancements with the missile, and they'll see if they can hit it.
Wow. So is a target a kind of like a type of rocket that you basically just get it up in the air, it's a target, and then the missiles fire at it?
Yeah, so usually for a target, you just think completely ballistic trajectory and you just kind of shoot it that way and you go, okay, here we go. It's going to just do this parabolic trajectory and hit however far away it hits. And then you plan it out well. And then someone else does a missile that maybe can maybe it has some sort of ability to track it or something like that, right? You hear about that kind of stuff in movies.
So if you want to take your skeet shooting hobby to the next level by like 10,000, you get into targets and missiles.
Yeah, absolutely.
Sorry, I didn't mean to cut you off. I had to throw the joke in there.
It was a good one. I like it.
Thank you. So not too many certificates or certifications other than maybe learning to code. Learning that skill is essential. But do you necessarily need a certificate or certification in that? Do you have to go to a coding boot camp, or is it just if you know the skill, then you're good to go. You're well on your way?
If you know the skill, you're well on your way. It's kind of one of those things that is really secondary to a lot of the aerospace engineering classes and coursework. Mm-hmm. And a lot of times they'll actually give projects in school that if you know how to code, they'll actually be easier, and you'll actually be able to get through them faster and spend more time, learning the math behind it, instead of going through and working on the programming. And then, once you get into the industry, then you code, it becomes second nature. Mm-hmm. That, I know how to code, so I'm going to go through and code that. So it's not all pen and paper. And a lot of it is behind a computer, and computers only do what you tell them to do. And there are computers on rockets that are going to tell it what to do, and all of that's code.
As a GNC engineer, that's guidance, navigation, and control, do you necessarily need to have skills in computer-aided drafting software?
So it depends on it depends. So you can definitely have that skill, and a lot of our mechanical engineers do have that skill. We actually will go through and draft up what the rocket's going to look like in CAD, and a lot of times our aerodynamics engineers will take that and they'll use that to do computational fluid dynamics. They'll actually go through and take a computer model of the outside of the rocket and see what happens when you put it at different angles at different speeds through the air. And that when they do that, they use a lot of CAD.
So so that I'm painting the correct picture in my head, if I'm looking at the CAD screen and I'm building my missile, this is my missile right here. I'm building my missile and I'm like checking out the fluid dynamics, and I want to see if it's, how it's going to interact with the wind. Make sure it's, I can't even think of the word right now. It's the end of the day. Words are so hard. Aerodynamic. And I'm looking at the computer screen, and that's kind of what I'm doing in CAD is I'm looking at this, I'm building this model, and then I'm running simulations.
Exactly.
I love it. And in those simulations, are they able to duplicate, like recreate different kinds of environments, such as, it being hot and humid, it being hot and dry, cold and humid, cold and dry, different elevations? Is that also programmable in those simulations?
Absolutely. We'll try and make it so that we can really put that rocket through what it might actually see. And so we'll actually go through and run that, in a simulation where we put it at Mach whatever it's going to go. And we'll see what it's gonna behave at supersonic speeds, and then we'll actually go through and compare that to a lot of times to a wind tunnel, if we can get one that will make it go fast enough.
Oh wow! So once you bring it from the CAD file to real life, you put it in a wind tunnel to actually run more tests on it?
Yeah, so that's just actually something that we do to verify, because we can actually verify a lot of the output of those simulations before an actual launch or flight. And so whenever we can test something, we try and do that, and that's usually a pretty standard one that we'll try and do.
I mean, that makes sense. I would definitely want this thing to work the way it's intended to work. I imagine these rockets are probably in the at least multi-million dollars to manufacture, and even more so to test.
At least, usually some tens of millions will go into it, depending on where you need it to go.
Wow. So tell us about a project in the life of Eva, Guidance, Navigation, and Control Engineer.
So the project that I'm working on right now, it's right above my head on the screen, actually. So that is a lunar lander, and that's something that I'm doing with Masten Space Systems. And essentially, right now, we're kind of in the middle of development. So what we've done so far is we've kind of talked to the customer to try and get an idea of what the customer is looking for. And in this particular case, our customer is NASA, but NASA is doing this for a purpose, and the purpose is that we're going to put some payloads on the moon. And so we really want to get a chance to talk to NASA, talk to the people who are making these payloads, and understand what it is that is required for them to be successful. And so there's a whole phase of just that, just understanding really what is going to make everybody happy. Then we'll go through and we'll actually start doing a preliminary design phase. And we'll go through and we'll say, okay, based on that, I think that we need these motors and these actuators, and we think the spacecraft is going to look like this and is going to be this heavy, and the solar panels are going to be in this spot. And then we'll go through and we'll actually start running simulations and start doing analysis to try and check out our design. And we iterate. So as we go through and do that, we may see that some of the payloads maybe wouldn't be so happy, and so we need to go back and redesign. Or maybe we can land on the moon, but maybe it's not so accurate. And we'll go through and we'll revise it. Right? We learn new information through that process, and we'll go through and revise it. So now we're in what is usually called a critical design phase. And that's when things are really coming to a point, and we're trying to really solidify everything so that we can actually go through and start building and programming and getting things to the state that we need to, so that we can test it. So we're going to be going through and we're going to test stuff. And that's one of my favorite parts, because working on launch vehicles for so long, it is pretty inspiring to stand behind a giant rocket nozzle and move things around and make sure that nozzle moves in the right direction and make sure that everything is working the way that you intended for it to work. And then after that, we put everything together and see what happens.
Wow, that is incredible. It's project management is project management. Troubleshooting is troubleshooting. And hearing you describe the whole process is kind of reminding me of the entertainment industry, and when you build a performer flying system, the way you design it in CAD, and then you test it and you put the weights on it and you test it before you put a live person on it. Now you put a live person on it, and there's all the reiterations, all of the testing, and then the fixing, and etc. But that is just so incredible, and it's so empowering. I love that you mentioned that your client is NASA, because I would think that if I wanted to get into this, I would only think about NASA. That's like the only NASA and SpaceX. I wouldn't even know what other companies to try to pursue. So with that said, can you describe some entry-level jobs that someone new to this industry could go into, and maybe what companies those jobs may be, where these people could go?
Absolutely. So Masten Space Systems is actually a really small company. For a while, they only had maybe 20 employees that were kind of working on some vertical takeoff and vertical landing type landers. So Masten has landed on the Earth for many years now. This is just going to be our first opportunity to land on the moon. But there are tons of companies. Previously, I've worked for Northrop Grumman. There's a lot of other companies like Boeing. There's Lockheed Martin. There are tons of companies that are big, right? Not everybody is going to be able to work at some of these smaller, more commercialized. I'll call it new space. There's a lot of old space that still needs to happen and still needs to get done. And NASA is very selective, and they also contract out a lot of their work. So a lot of times, and I didn't realize this too, because I always thought, well, I want to work for NASA. And I mean, I still want to work for NASA. I do. But I realize that a lot of times they contract out to these other companies. And that is really how you get to work on one of those NASA projects without actually having to get through all of that interview process, because there's only one NASA, and there's so many other big companies to work for. And usually, if you have a bachelor's degree, you start out as an associate engineer, and that's essentially, they'll know that they're going to have to do some training. I actually joke a lot because very very few schools will offer classes that are specifically for guidance, navigation, and control. So a lot of times you get an associate engineering position and you emerge as a GNC engineer, because maybe you get a chance. I think I took maybe 2 control classes in school, and that's one of 3 letters. I didn't take any guidance classes or any navigation classes, and yet still I was able to learn on the job. And so those entry level and mid-level jobs are really there to teach you what it is that you need to know, because it's huge. There's so much that goes into it, and maybe you get there and you realize that you're really good at trajectory optimization, or you're really good at aerodynamics, or you really love actuator systems, and they're all pieces that go into GNC, but you can't go to school for them. I don't think I've ever taken a class specifically about actuators.
So how well did college prepare you for your career? You mentioned that you have had a lot of on-the-job training. So can you describe how you think college was able to prepare you for your career?
So I also I have a bachelor's in astronautical aerospace engineering. I also have a master's degree, and that prepared me a little bit more, because there's so much that goes into aerospace engineering. A lot of schools actually think that it should take 5 years to go through and do an aerospace program, but in order for it to be an accredited program, they have to be able to fit it in to 4 years. And so
that's crazy.
It is.
That's actually pretty insane.
So, but a lot of times, right, they know that in order for you to be fully prepared to go and hit the ground running in an industry that you have a decent chance at needing to know how to code. But they don't necessarily require you to learn how to code as part of school. They'll teach you, right, the skills that are harder for you to learn on the job, and kind of leave it to you as a person, as well as, you know, your future employer, to take that and say, okay, you have a general idea of how to think logically. Now you can actually go through and learn how to code. If you know how to code, they can spend some time teaching you something else, right? So there's usually just some piece that maybe you don't know on your first day, but you'll know on your 365th day.
That's some pretty serious industry insight right there.
Yeah.
So what's your master's degree in?
So it's also in aerospace engineering, but it doesn't have a fancy qualifier.
And what made you pursue your master's degree? Is a master's degree something that anybody in this field should pursue?
You don't necessarily need a master's degree. I really wanted a master's degree because when I got out of my bachelor's degree, I was a little bit surprised. I had gotten through all of these classes and I thought, wow, like I knew I liked space and I knew this was something that I wanted to do, but you know, holy moly, like that was a lot. And I hadn't had a lot of opportunities in my undergrad to take advantage of doing an internship or to do something a little bit more hands-on. I learned a lot, but I spent a lot of time learning it. And I just didn't feel like I was done. I wanted to learn more. And so I decided to pursue a master's degree. And my whole goal for my master's degree is I wanted to make something with my hands. Which was also very short-sighted because I could have just coded something behind a computer and I probably would have been better off. But I did actually, I did make something with my hand. I was able to, by the end of my master's, I was able to make a solar cell.
Oh, that's cool.
All by myself, actually, which was really, really amazing and not really that useful for my industry. It would have been very useful if I was into electrical engineering or power systems or that type of thing. But but I learned a lot about solar panels in space and how they would be used in that way, and a lot of what goes behind that and how to make them more efficient. And I learned a lot of engineering skills, but not specifically guidance, navigation, or control.
Wow. So the hardest part about being a host is like listening to everything that you say, and then I just want to soak it all in and then marinate in it and think about it for a second. But then I've got a show to run, so I got to respond with something. But you know, I don't know. I'm sorry that your project was not really all that useful to you in the long run. But hey, maybe it will be. I don't know. Are there solar cells on your on the lunar lander?
There are. And I actually think that it was really, really useful for me and my career. I mean, I did have a goal that I wanted to make something with my hands. And I was able to do that and accomplish it. And I learned a lot. And I actually had the opportunity to go to a conference, which I think feeds into something else that we're going to talk about later.
It totally does.
I was able to go to a conference, and it was Space Photovoltaic Research and Technology Conference, and it was at the NASA Center in Ohio. And I remember sitting in a conference room, and they were going through, and there were a lot of people that were presenting about, you know, how you would use solar panels to power a spacecraft or a vehicle in space. And then there were a lot that were actually going through a little bit more from a design perspective. How would you go through and design and scientifically go through and test these solar panels? And I realized actually at that conference, I was very, very grateful to have had that experience. But I realized that I was so interested in all of the spacecraft and the mission design, you know, behind the actual spacecraft and the space exploration part of it. And I maybe fell asleep a little bit. during some of the presentations that were about a little bit more of the nitty gritty part. And so it really helped me choose, and it helped me know that I wanted to do something that was more on the spacecraft side, more on the spacecraft and mission design side, as opposed to actually going through and developing and learning about the inner workings of the actual solar cells.
That makes a lot of sense. One of my biggest tips for anybody in high school or, recently graduated from high school is that if you don't quite know what you want to do, just go play. Just go play around, go try things, build a solar panel. If you like it, then great. You like it. If you hate it, then that's not the direction you want to go in. So, you know what? You're absolutely right. I think that's a fantastic mindset to have. Are there any other conferences and trade shows that someone new to this industry might want to check out?
Yeah, so there are tons of conferences that are put on all the time that are aerospace related. The most common ones are usually with AIAA. That's the biggest aerospace professional network that at least I've heard of, and they put on several. And so I would definitely recommend checking out their conferences.
AIAA. What does that stand for?
Aeronautical.
I will do it too. AIAA. American Institute of Aeronautics and Astronautics.
There we go.
What's the difference between aeronautics and astronautics? Is it aeronautics are planes and astronautics are spacecrafts? Is it as simple as that?
That's probably the simplest way to go about describing it. Astronautics are usually things that are outside of the atmosphere, and aeronautics are usually inside the atmosphere.
Gotcha. So technically, then wouldn't that technically make you an astronautical engineer since you're working on a lunar lander?
Right now.
Moon.
Yeah. So, but both are aerospace engineers. Gotcha. And when I had selected which version of aerospace engineering to go into, those were the options that I had. I could do the astronautics focus and learn more about orbital mechanics and spacecraft, or I could go aeronautical focus and learn a little bit more about computational fluid dynamics and aircraft and aerodynamics that way.
I know you have some of your colleagues that are tuning in and watching, and I'm sure I'm making a little bit of a fool of myself because, a lot of what you're saying is going way over my head, but that's okay. And if it's going over the heads of my target audience too, that is totally cool too. If you are really into space and exploration, aeronautics, astronautics, any knots, just kidding. When you're watching a live stream like this, just pick out the vocabulary that Eva is throwing out there and just start Google searching that kind of stuff. Start to get familiar with the language that's used in these spaces, and that's going to kind of help you figure out what direction do I want to go in. Okay, maybe this sounds interesting, maybe this doesn't. When did you know that this is what you wanted to do? Did you always know you wanted to be a GNC engineer, or did that come while you were in college or after college?
So that GNC, I started to pick up on after I got my bachelor's degree. And I was kind of looking through and I thought, now that I decided I'm going to get my master's degree, I need to really take this seriously and really get a chance to learn what I might be able to do. And so I actually went job searching after my bachelor's degree, before my master's degree, and I actually printed out a job requisition for, it was at that particular time, it was orbital sciences. It was such a long time ago that it was orbital sciences. And I printed out several of them. I think I was interested in systems engineering, I was interested in propulsion engineering, and I was interested in guidance, navigation, and control. And I printed them all out and I looked through and I found classes that were in common with them. You must have experience with, this random keyword, right? Mm-hmm. And I made it my goal as part of my master's to match what classes that I was taking with these job requisitions. And that actually helped me a lot, because as I was going through and I was learning about controls, I thought, oh, well, I really like that, but that's not on the propulsion engineering job rec. That's only on the GNC job rec. And so then I could actually go through and the next semester, when I was choosing classes, I picked more of those to make sure that that's actually something that I really, really wanted to do. And then by the time I was done with my master's degree, my resume and the job rec could have been the same.
That is some serious industry insight. I never would have thought of that. Even, being almost 10-ish years into my career. I think it's been 8 years, almost 10 years. I never would have thought about that. That is a really, really great strategy. And so that kind of helped you learn about, gain more awareness of GNC engineering. At least when it comes to space exploration, how young were you when you knew that's what you were passionate about?
I definitely knew that I liked space from a really, really young age. I remember being in second grade and having a poster over my bed with all of the constellations, and I was just absolutely obsessed with the constellations and the thought process of going into space and all of the different planets. But I never knew what an engineer was, or really what I would be able to do in order to get there. I thought that I wanted to be a teacher for a really long time, because teacher was just about the hardest profession that I could imagine, because that was also the hardest profession that I saw. Right, you know, as a kid,
right?
My dad worked for the post office. My mom, she can do anything, but she was doing things like real estate and tax preparation. And all this kind of stuff. And I thought, those don't seem very interesting. And so the next person that I knew was my teacher. So I think I went all the way through until high school, thinking that I wanted to be a teacher. And then when I got to high school, I finally took a physics class and then an astrophysics class. And then I thought, oh, that must be how I go to space. And actually, the astrophysicists don't go to space. The astrophysicists sit at telescopes and look into space. But the engineers were the ones that go to space.
How do you practice work-life integration? I say integration and not work-life balance, because sometimes, some weeks are going to demand more time spent at work. Sometimes you got to prioritize your family. Sometimes you got to prioritize yourself. How do you do your whole work-life integration as an aerospace engineer?
So work-life integration, if you only concentrate on certain projects or certain times, it feels a lot different than if you look at the big picture. Right. And I had talked about kind of iterating through and all of these different cycles of design. And so a lot of times, right, at the beginning, maybe things are a little bit more relaxed. And then, a deadline approaches and things get a little bit busier. And then, right immediately after, then there's a little bit of a lull, and then you're prepping to actually go through and launch something and have a flight. And then it's you're going crazy. You're trying to, make sure that everything is good, and you're crossing your T's and you're dotting your I's, and it feels like it's very, very busy. But looking at it as a big picture, it's fun. It's kind of like this cycle of really busy times and then more relaxed times. And I've really found that, someone actually once told me, you show up when you need to show up, and you go home when you need to go home. And that was really important advice, because sometimes don't work just because you think that you're supposed to work on something that's actually going to bring value, and rest if there's not, because there's about to be a lot of work to do. And so kind of differentiating between those, and learning that it is kind of a cycle. And if there is a lull, spend a little bit more time, with yourself and your home life. And then when it's time, then you put forth the work.
I think that needs to be on a t-shirt and on a mug and anywhere where you can print something, because everybody should be reminded that you work when you need to work and you go home when you need to go home. And it's super important to recognize and differentiate between the two, and know, just prioritize and execute whatever needs to be done at the appropriate time. I love that advice. I w- I welcome to you to tell us about what your experience has been like as a woman in STEM. I feel like I'm gonna leave this open ended because I feel like a bunch of like ideas are gonna pop into your head right now. So go ahead, floor's yours.
I'll use a story to kind of dive into it a little bit. At a previous job, I had a program manager who answered a very important question that someone asked. They said, what's the dress code for this design review, right? It's going to be one of those design reviews. The customer is going to be there. And they were curious. They just wanted to know, what should we wear? What's the dress code? And the program manager said that the dress code was to wear a tie. And so I showed up in a tie. And it was a little bit awkward because not everybody immediately realized the reason that I was wearing a tie. Everybody sort of knew, oh well, so and so said that we should wear ties, and it was actually very interesting. The other women immediately understood what I was doing, and it took a little while, right? I had to explain it to them. I said, you forgot that you're not just talking to a group of men, right? There are, and actually there were a lot of women engineers on that team that were also, leads for their respective disciplines. And it's just really important to talk to everybody. It's not just having a seat at the table. It's also being recognized as being at the table.
Yeah.
And more so, and not just not discluding someone, but making sure that they are included.
Mm-hmm.
And I think has really been the key for me, as a difference between whether or not I feel good in a particular environment or not. Is, a lot of times people think, well, we're not doing anything to prevent women from being here. And it's like, well, yeah, but are you doing things to purposely include us? Because if not, most women will look and they'll say, oh, well, that's a job for men, because clearly there's just a bunch of people that are there that are wearing their ties, and that's for them, and I don't belong in that room. But if we spend extra time to make sure that women know that we actually do really, really want women to be there, because the perspective is really valuable, and we're going to think about things in a different way that is a different set of ideas, that without them you just get there's less creativity. So those extra ideas are really, really important, and we need to be purposely including women that are interested, so that we don't miss out on those really important perspectives.
Mm-hmm. I love the way you subtly challenged that status quo. Not even the status quo, but just that person's perspective and the way that they were viewing the world.
Yeah, they didn't think to specify the difference between
business formal.
Just business formal. That in itself would have been absolutely fine, because then if I didn't know what business formal was, I could Google it. But no, it was tie. So I did it. I wore a tie.
That is so, I really admire you for that. I think that's absolutely fantastic. And you're right, representation absolutely matters. And it's really important for anybody to see themselves as capable of being in those types of positions, any position really. I say those types of positions, but it could be anything in STEAM or outside of STEAM. And I say STEAM because I like to throw the A in there for arts,
Absolutely.
because you need those designers, you need those people with that artistic eye. Kudos to you for that. That is amazing. I, you know what? I can't wait to have a conversation with you off the air. But right now, we've got to conclude this show. And do you have any final industry insights or thoughts you would like to leave our audience with?
I just want to say to pretty much everybody, I've been told a lot in my life that I can't do something, and so many times.
That just grinds my gears.
And the important thing that I found is to prove it, right? If you think that you want to do something, and aerospace engineering is hard. It's hard, but it's not impossible, and it's not unlearnable, and it's definitely fun. And so if it seems like it's hard and you feel like you can't do it, or somebody tells you can't do it, just try to do it and prove that you can or can't. And if you fail the first time, understand also that even rockets will sometimes fail, and we learn and we try again. And we go through the different design cycles because sometimes we make mistakes and we iterate, and we can do that as humans too.
That is fantastic advice. Thank you for including that metaphor. Failure is a part of learning, and it's a part of growth, and it's a part of every single part of life, including rocket science. Thank you so much, Eva, for being on the show, and thank you for dropping so many industry insights and so much vocabulary. This was so much fun. I don't get to wrap this up because someone wants to ask a question. What is your favorite engineering plot you have ever seen and either made you proud or happy? Italian Reptart wants to know.
So I remember actually one time there was a plot that someone made for me, and they were a new engineer, and we have to do what's called Monte Carlo simulations. And essentially what that means is that we take all of the different possible outcomes of something, and we say, okay, we're going to try as many of them as possible, and we'll run through, and we do 1,001 of them. And so, but a lot of times we'll actually go through and we'll put plots and show plots to the customer to show that we're going to meet requirements. So it'll be something like how much fuel you use. We'll go through and show that. And this new engineer made a whole bunch of plots for a design review, and the default color scheme for plots is to use each new line is a new color. And so there were 1,000, like just default 1,000 colors essentially on this plot. And they expected me to show this in a professional setting and in fact, it actually looked like an 8-year-old took a 96 pack of crayons and swiped it over the computer screen. And so then we learned about how to make a better plot. And so my favorite is where the best outcome is blue over gray in the background. But it's I was proud that at the learning experience. But that kind of goes to show too, just because you're new at something and you give something a go, you learn, and default color settings in MATLAB are not necessarily the way to go.
Well, thank you for answering Italian Reptar's question. If there are no other questions for this live stream, then I'm going to close it out. Eva, thank you so much for being on this show. I'm excited to have more conversation with you. Oh, it happened. I'm not allowed to leave. I can't leave. Williams Samuel, I don't know how to pronounce your last name. I apologize. Asks, which school is best for studying aerospace engineering? Great question.
Oh, any school is okay. So I went to Arizona State University, And I did that mostly because it was really close to home and I didn't want to move away from my family. And I also was not in a situation where I could afford to go to, one of the, I'll call it a fancier school, or pay out of state tuition. And so I went to Arizona State. I actually got a full scholarship to Arizona State, and so I didn't have to pay out of pocket to go to school at all. And that was really, really important to me. I couldn't afford to take out student loans or anything like that. If money is not an issue, I feel like I would have gone somewhere like I don't know, Caltech or Georgia Tech or University of Michigan or UC Boulder or somewhere like that. I've seen a lot of really great engineers come out of those schools, but those schools evolve, and different professors come in, and sometimes different professors can really make or break it. But you always get what you put into school. If you try your hardest, it doesn't matter what school you go to, you're going to be okay, as long as you're giving it your all.
We have a group consensus saying, "Go Jackets, go Jackets." Mark O'Brien tuning in saying thank you guys for tuning in. It's always great to have you. Williams, thank you so much for your question. That's a really good one, and a lot of students they either want to know what college degree, what do I need to major in, or where do I need to go to school. So thank you, Eva, for answering that question. Any other questions from our audience members? Thank you guys so much for tuning in. As I wait for more questions to come in, if they do come in, I would like to remind you guys to please subscribe to Industry Explorers on YouTube and check out our upcoming videos. We cover all kinds of industries and all kinds of careers because we're here to help you figure out where you want to go. How do you want to navigate your life? We're here to give you practical tips and advice, and just come explore with us. Even if you're established in a certain career, come check out our videos anyway, because you'll learn something about a whole other career you never knew about before. One of our upcoming live streams is about entertainment rigging. That's where I come from, so I'm pretty excited about that one. Again, subscribe to our channel, and if there's no other questions coming in, I'm going to close out this live stream. Eva, for the third time, thank you so much for being my guest on this show and for answering these really great questions and for helping people figure out what it is that they want to do. Hopefully someone has discovered themselves in some way, or at least broadened their vocabulary. I know I have. And with that, explorers, I will see you guys on our next adventure. Take care, everybody.